A long rectangular sheet of metal, 12 inches wide, is to be made into a rain gutter by turning up two sides so that they are perpendicular to the sheet. How many inches should be turned up to give the gutter its greatest capacity? When I first read greatest capacity and I see this picture, I'm thinking volume. I'm thinking, what's the greatest amount it can hold, which would be its volume. However, when I look at the shape, I have its width and I have its height, but I don't have its length. So I would need width times length times height to find the volume of this rectangular object. So instead, what I'm going to think about is its cross-section. So it's the area of this rectangle right here. If we can maximize the area of the rectangle, then we should be able to maximize its volume. So if we can find the maximum area, we would also be finding its maximum volume. So what we're going to do is make an area equation, since those are the values that I'm given. So I've got the area is length times width, but really let's call it width times height in this case. So I'm going to call this f of x, and then we've got the width is 12 minus 2x, and its height is x. I'm going to distribute my x, and I notice it's a quadratic, so now I'm going to write it in descending order. So I'm going to put the squared first, and then the 12x. So I see that I've got a quadratic. Now it wants me to find the maximum. So think about, what is the maximum of a quadratic? Well, if I graph this one, I notice it has a -2 in front, which means that it is going to open down. So generally, I know it's going to look something like that, where it opens down. Now its greatest capacity will be its maximum value. So it's going to be wherever it hits its maximum is going to be that greatest area. So I want to look for the vertex. So the vertex is going to find my max, and vertex you're going to do -b over 2a to locate the x value of the vertex. So the b of this is 12, the a is -2, 2a. So I get -12 over -4, which is 3. That means this is the height, because that is the x. This is how many inches should it be turned up to give the gutter its greatest capacity. And so that would be 3 inches. If you fold it at 3 inches, that is going to be its greatest area of the cross-section and then give you the greatest volume. Another way to do it would be to not find the vertex using -b over 2a, but instead take these two factors and set them equal to 0. If you set this one equal to 0, you get 6, and if you set x equal to 0, you get 0. And then if you find the average x, because that's telling me that it's crossing at 0 and it's crossing at 6. So if you find the middle value, which is 3, then you know where the vertex is going to be. Or you could add these and divide by 2 if you don't just naturally think about the middle being 3.